We measure power by what we can survive. A Category 5 hurricane makes landfall, and we watch in awe as concrete shatters and coastlines are erased. We call it apocalyptic. We name these storms, study their chaotic trajectories, and believe we have witnessed the ultimate manifestation of nature's fury. But this is a comforting illusion. What we call a catastrophic weather event is nothing more than a microscopic friction of warm air and shallow water, a fleeting thermal correction on the thin outer crust of an unremarkable rock. Out there, in the pitch black of the cosmos, the definition of a storm fundamentally changes. The universe does not deal in gentle pressure drops or localized rainfalls. It deals in scales of violence that our brains are simply ill-equipped to process. Imagine a cyclone wide enough to swallow 3 entire Earths, raging without a single moment of pause, since long before the first human empires were built out of mud and stone. Think of winds moving not at a fraction of the speed of sound, but accelerating so violently they become a relativistic force, tearing the very atomic structure of matter apart as they whip around the crushing gravity of a collapsing star. We live in a sheltered terrarium. The atmospheric disturbances we fear on Earth are merely a gentle sigh compared to the atmospheric slaughterhouses churning across our galaxy. There are worlds where the rain is not made of water, but of molten iron. There are exoplanets permanently locked in a deep freeze on one side, while the other side boils under a relentless host star, creating an eternal supersonic shockwave of wind. This boundary line carries dense clouds of vaporized rock and jagged shards of glass, slicing horizontally across the alien sky at thousands of miles per hour. This is not science fiction. This is standard atmospheric thermodynamics operating beyond the fragile safety net of our pale blue dot. To look up at the night sky is to look at a silent, seemingly peaceful canvas. But that silence is a lie told by distance. The vacuum of space is a perfect insulator of sound, hiding the deafening roar of stellar hurricanes, magnetic typhoons, and plasma storms that can sterilize entire solar systems in a matter of hours. The mechanics of the cosmos are utterly indifferent to our existence, driven by equations of heat, gravity, and momentum that demand absolute resolution, no matter what stands in their way. If you seek the unvarnished truth in the dark, and if you are willing to confront the terrifying mechanics of the real universe, subscribe and join us on this journey. Because to understand what weather truly is, we must leave the comforting illusion of our atmosphere behind and step directly into the crushing depths of the abyss. For thousands of years, our survival depended on our ability to look at the sky and predict the immediate future. We watched the migration of clouds, the shifting of the winds, and the color of the horizon at dawn. We built an entire branch of science around these observations. In 350 BC, Aristotle authored a text called Meteorologica, attempting to categorize the mechanisms of evaporation, wind, and rain. He believed that the weather was a localized phenomenon, an interplay of earth, air, fire, and water confined to our immediate atmosphere. For centuries, this was the absolute limit of our meteorological ambition. We mapped the trade winds to navigate sailing ships across oceans, and we studied the agonizingly slow movement of high and low pressure systems to protect our harvests. We developed equations of fluid dynamics to make sense of the chaotic swirling of water vapor. We convinced ourselves that we understood the architecture of a storm, but our understanding was tragically incomplete because our sample size was exactly 1. We built our entire intuition about weather based on the unique, highly constrained conditions of Earth. Here, the temperature variations are mild, the atmosphere is a thin, fragile skin of nitrogen and oxygen, and the solid ground acts as a massive braking system for any wind that gathers too much speed. To understand the true nature of a storm, we must abandon the concept of rain and wind entirely, and instead look at the cold, merciless mechanics of thermodynamics. The universe is a machine that hates imbalance. When one region of space is significantly hotter than an adjacent region, it creates what physicists call a thermal gradient. The laws of thermodynamics dictate that this heat must be redistributed until equilibrium is achieved. A storm is nothing more than the physical manifestation of the universe trying to forcefully flatten that gradient. The mathematics governing this process reveal a ruthless proportionality. The greater the temperature difference between 2 points, the more violently the surrounding matter must move to correct it. On Earth, the temperature difference between the warm equator and the freezing poles is perhaps 100 degrees Fahrenheit. This slight imbalance is enough to spawn Category 5 hurricanes. Now scale that mathematical relationship up to the parameters of the deep cosmos. Our first real glimpse into the terrifying mechanics of extraterrestrial weather came not from modern space telescopes, but from the brass and glass of the 17th century. In the 1660s, astronomers peering through early refracting telescopes noticed a distinct blemish on the banded face of Jupiter. They were looking at the Great Red Spot. It is a high-pressure anticyclonic storm so massive that 3 entire Earths could be dropped into its churning vortex with room to spare. It has been raging continuously since before the invention of the steam engine. For centuries, the longevity of this storm was an unsolvable mystery. On Earth, hurricanes are ephemeral. They are born over warm ocean waters, feeding on the rising thermal energy. But the moment they make landfall, they are doomed. The rugged topography of continents acts as immense friction, physically tearing the organized convection of the storm apart, bleeding its momentum until it collapses. But Jupiter is a gas giant. It possesses no solid surface to break the friction. It is a bottomless, crushing ocean of hydrogen and helium that gradually transitions from gas to a supercritical fluid the deeper you go. Without the predator of solid ground, a storm on Jupiter can feed on the internal heat radiating from the planet's core indefinitely. The winds at the outer edge of the Great Red Spot scream at over 400 miles per hour, deep within its roots, extending hundreds of miles below the visible cloud decks. The atmospheric pressure is so immense that the structural integrity of molecules begins to fail. The physics of our earthly storms look like gentle thermodynamic rounding errors compared to a vortex that has chewed through the atmosphere of a gas giant for 400 years. Yet, as our observational technology grew more sophisticated, we realized that even the violent atmosphere of Jupiter is a relatively calm environment. When we look beyond our solar system, the equations of atmospheric physics are pushed to their absolute breaking points. 64 light-years away, in the constellation of Vulpecula, there is an exoplanet designated HD 189733b. It is a gas giant, slightly larger than Jupiter, orbiting incredibly close to its host star. If you could view this planet from a spaceship in orbit, it would look deceptively beautiful. It glows with a deep, serene azure blue, highly reminiscent of the tranquil oceans of Earth. But that color is a deadly optical illusion. The blue is not scattered by water vapor. It is scattered by an atmosphere choked with silicate particles. This planet is tidally locked, meaning its orbital mechanics force one side of the planet to permanently face the searing heat of its star, while the dark side is perpetually exposed to the freezing vacuum of deep space. The thermal gradient here is not a few degrees, but thousands of degrees. The mathematical imperative of thermodynamics steps in with absolute fury. The atmosphere on the day side boils and expands, violently rushing toward the cold night side in a desperate, unending attempt to balance the temperature. This generates a perpetual planet-wide jet stream howling across the terminator line, the boundary between day and night, at velocities exceeding 5,400 miles per hour. That is 7 times the speed of sound. In an atmosphere filled with silicates, the extreme heat causes the minerals to condense. The result is a world where it rains jagged shards of glass. And because of the supersonic atmospheric flow, this glass does not fall gracefully to the ground. It is driven horizontally, a perpetual planet-wide storm of razor-sharp shrapnel, moving fast enough to instantly disintegrate any engineered material we have ever conceived. We know this not because we have captured video of the storm, but through the flawless logic of spectroscopy. We analyze the light of the host star as the planet passes in front of it. As the starlight filters through the very edges of the planet's atmosphere, specific chemical elements absorb specific wavelengths of light, leaving dark, telltale gaps in the spectrum. But because the atmosphere is moving at such apocalyptic speeds, the light itself is physically warped. This is the Doppler effect. But instead of the changing pitch of a passing ambulance siren, it is the fundamental color of reality being stretched and compressed. As the supersonic winds blow toward our telescopes on one side of the planet, the light waves are compressed, shifting the microscopic fractions of a nanometer toward the blue end of the spectrum. On the opposite side, where the winds are racing away into the night, the light waves are stretched, shifting them toward the red. By measuring the infinitesimal difference between that red and blue shift, astrophysicists can calculate the exact velocity of a windstorm raging trillions of miles away in the dark. The math does not require belief. It simply reveals the brutal architecture of the universe. As we refine these models, a more disturbing realization takes hold. Our entire definition of weather is biased by the assumption that a storm requires a physical atmosphere, that you need a gas or a liquid to carry the energy. This is a fatal failure of human intuition. The most destructive weather systems in the cosmos occur in an absolute silent vacuum. A star is not a solid, peaceful sphere of light. It is a terrifyingly unstable ocean of plasma. The temperatures are so extreme that atoms are physically ripped apart, separating negatively charged electrons from their positively charged nuclei. This creates a hyperfluid of pure electrical charge. Moving electrical charges generate magnetic fields, and inside a star these fields are braided and twisted into knots of incomprehensible complexity. The fluid dynamics of plasma do not behave like the air currents of Earth. They behave like tightly wound steel cables under immense tension. The equations governing magnetic flux dictate that this tension cannot build forever. There is a mathematical limit to the stress a magnetic field line can endure. When that threshold is crossed, the magnetic lines snap and violently realign into a lower energy state. The energy released in this single fraction of a second is equivalent to millions of nuclear warheads detonating simultaneously. This is a solar flare. Often, the localized explosion is so violent that it physically tears a piece of the star's outer atmosphere away, hurling billions of tons of magnetized radioactive plasma out into the vacuum of space at millions of miles per hour. We call this a coronal mass ejection. It is a hurricane of invisible radiation, a storm of pure magnetism and subatomic artillery. In September of 1859, our planet took a direct hit. The English astronomer Richard Carrington was observing the sun, projecting its image through his telescope onto a piece of paper, when he witnessed a blinding white flash erupting from a cluster of sunspots. It was a visual confirmation of the magnetic snapping process. 18 hours later, the resulting wall of radioactive plasma slammed head-on into the Earth's magnetic field. The impact violently compressed our planet's magnetosphere. This rapid compression induced massive electrical currents that surged through the Earth's crust. In 1859, humanity had only just begun to wire the world with electricity. The global telegraph network acted as a massive antenna, absorbing the geomagnetic-induced currents. Telegraph pylons across North America and Europe literally burst into flames. Operators were thrown from their desks, shocked unconscious by their own equipment. In a surreal display of the storm's invisible power, telegraph operators were able to disconnect their batteries and continue transmitting messages, the lines completely powered by the ethereal, surging energy of the solar hurricane. The night sky ignited with auroras so bright that gold miners in the Rocky Mountains woke up and began making breakfast, believing the sun had risen at 1 in the morning. The Carrington event was a terrifying demonstration of how fragile our planetary shielding actually is. Today, we do not rely on simple copper telegraph wires. We have encased our entire civilization in a delicate, hypersensitive web of microchips, fiber optics, GPS satellites, and fragile high-voltage power grids. We have built a digital nervous system that is highly allergic to magnetic induction. If a solar storm of the exact same magnitude were to strike the Earth this week, the resulting electromagnetic surge would instantly overwhelm transformer stations globally. The latency of global servers would not just spike, the physical hardware would melt. Satellites would short-circuit and drift blindly out of orbit. Entire continents would be plunged into a silent, catastrophic darkness. Cities would empty out, powerless and paralyzed, resembling the decaying concrete husks of an ancient ruin. We live under the constant threat of a weather event that requires no clouds, no wind, and makes absolutely no sound. Yet, Even a Carrington-level event is a localized breeze compared to the meteorological horrors hidden deeper in the galaxy. We tend to view the space between the stars as an empty void, a peaceful emptiness separating the solar systems. This, too, is an illusion. The interstellar medium is a highly dynamic fluid. It is filled with the freezing interstellar wind, a thin but relentless gale of gas, dust, and cosmic rays moving between the spiral arms of the Milky Way. Our entire solar system is encapsulated in a magnetic bubble generated by our Sun, known as the heliosphere. As our Sun orbits the center of the galaxy, it drags this bubble along with it, plowing through the interstellar wind like a submarine navigating a deep, dark ocean. There is a massive bow shock ahead of us, a colossal pressure wave, where the expanding atmosphere of our Sun violently crashes into the incoming tide of the galaxy. We are floating through an environment that is fundamentally hostile, completely at the mercy of thermodynamic and magnetic laws that operate on scales of thousands of light years. And as our instruments begin to peer past the edge of the heliosphere, looking out into the deep cosmic weather patterns, we are discovering phenomena that defy every physical model we have ever written. Out there, in the dark, we have found storms that do not just strip away the atmospheres of planets. They warp the very fabric of space and time, driven by engines of gravity so dense and so violent that light itself cannot escape the turbulence. To comprehend the architecture of the ultimate cosmic storm, we must mentally zoom out from the relatively localized neighborhood of our solar system and examine the broader structural dynamics of a galaxy. A galaxy is not merely a static collection of stars drifting peacefully through the void. It is a violent, churning ecosystem of gas, dust, and dark matter, all bound together by the invisible, inescapable architecture of gravity. At the heart of nearly every large galaxy, including our own Milky Way, lies a gravitational anchor so profound that it bends the very geometry of space and time. This is the supermassive black hole. For decades, these entities were considered mathematical anomalies, mere quirks in the field equations of general relativity. Physicists debated whether they could actually exist in the physical universe or if they were simply abstract limits where our understanding of mathematics broke down. Today we know they are not only real, but they are the engines driving the most apocalyptic weather systems in the universe. When we picture a black hole, we often imagine a cosmic vacuum cleaner, indiscriminately sucking up everything in its path. This is a fundamental misunderstanding of orbital mechanics. A black hole does not suck matter. It simply exerts a gravitational pull proportional to its mass, just like a star or a planet. If you were to magically replace our Sun with a black hole of the exact same mass, the Earth would not be pulled into it. We would continue to orbit in the exact same path, though the planet would quickly freeze in the sudden absence of sunlight. The true danger of a black hole only manifests when matter gets too close, crossing a threshold where the gravitational gradient becomes overwhelmingly steep. When immense clouds of interstellar gas or wandering stars are captured by this gravitational well, they do not fall straight in. Because of the conservation of angular momentum, the same physical law that causes a spinning ice skater to rotate faster when they pull their arms inward. The infalling material begins to spiral around the black hole, flattening out into a vast rotating structure known as an accretion disk. This disk is the cosmic equivalent of a hurricane, but its mechanics are entirely alien to our earthly intuition. In a terrestrial storm, wind is driven by differences in air pressure and guided by the rotation of the planet. In an accretion disk, the driving force is pure gravity colliding with extreme friction. The mathematics governing this spiral dictate a brutal trade-off. As the radius of the orbit shrinks closer to the black hole, the velocity of the plunging matter must increase exponentially to resist the crushing inward pull of gravity. The matter at the outer edges of the disk might be moving at thousands of miles per second, which is already an unfathomable speed. But the matter at the very inner edge, skimming the surface of the event horizon, is being dragged around at a significant fraction of the speed of light. Because the inner layers of the disk are spinning vastly faster than the outer layers, adjacent rings of gas are violently grinding against one another. In the vacuum of space, this extreme friction does not produce a sound, but it generates an unimaginable amount of heat. The mechanical energy of the swirling gas is converted directly into thermal radiation. The temperatures inside the disk soar into the millions of degrees, ripping the electrons from their atomic nuclei and transforming the gas into a blindingly luminous, electrified plasma. This process of frictional heating is so staggeringly efficient that it can convert the resting mass of the infalling matter into pure radiant energy far more effectively than nuclear fusion. A star burning hydrogen in its core might convert a tiny fraction of a percent of its mass into light. An accretion disk can convert nearly 40% of the mass it consumes into raw, devastating energy. The sheer scale of this thermodynamic engine was first brought to our attention in 1963 in an observational breakthrough that shattered the astronomical community. An astronomer named Martin Schmidt was studying a mysterious celestial object known as 3C273. Through his telescope, it appeared merely as a faint blue star, but when radio telescopes pointed at the same coordinates, the object roared with an intensity that made no sense for a standard star. Schmidt analyzed the spectrum of the light coming from the object, passing it through a prism to observe the chemical absorption lines. What he saw was mathematically horrifying. The pattern of the chemical signatures, particularly the lines of hydrogen, were wildly out of place. They had been stretched, shifted far toward the red end of the electromagnetic spectrum. In the strict laws of physics, a red shift of this magnitude meant only one thing. The object was racing away from us at a terrifying velocity due to the expansion of the universe. By calculating the exact degree of the redshift, Schmidt determined that 3C273 was not a star in our local neighborhood. It was an object located 2.5 billion light-years away. For an object to appear that bright in our sky while being located billions of light-years in the deep past, its absolute luminosity had to be beyond comprehension. It was emitting hundreds of times more energy than the entire Milky Way galaxy combined, yet all of this light was emanating from a space no larger than our own solar system. Schmidt had discovered a quasar, a quasi-stellar radio source. He was looking directly down the throat of a supermassive black hole, actively feeding on its accretion disk. It was a storm of plasma and radiation so violent that its light could pierce the expanse of the observable universe. For decades, the existence of these accretion disks remained a matter of indirect observation and theoretical modeling. We could measure their radiation, but the physical objects were simply too distant, and the central black holes too small in angular diameter to be resolved by any telescope on Earth. To actually capture an image of the event horizon, the boundary where the storm ends and the black hole begins, required an optical resolution equivalent to reading the date on a coin resting on the surface of the moon while standing in New York City. No single mirror, no matter how perfectly polished, could ever achieve this. To overcome this physical barrier, humanity had to engineer a solution that leveraged the rotational mechanics of the Earth itself. In an unprecedented global collaboration, astronomers linked together 8 radio observatories scattered across the globe, from the high-altitude deserts of Chile to the volcanic peaks of Hawaii, from the mountains of Spain to the freezing desolation of the South Pole. This network was known as the Event Horizon Telescope. By perfectly synchronizing the observations of these disparate dishes using hyper-precise atomic clocks, they effectively transformed the entire planet Earth into a single, massive radio receiver. The target they chose was not in our own galaxy, but deeply embedded in the heart of Messier 87, a massive elliptical galaxy located 55 million light-years away in the Virgo cluster. The supermassive black hole at its center, designated M87 star, possesses a mass equivalent to 6.5 billion times that of our Sun. The sheer volume of raw data collected during the observation run was so immense that it could not be transmitted over the internet. The latency and bandwidth limitations of global servers would have bottlenecked the project for years. Instead, physically shipping half a ton of highly sensitive hard drives on commercial airplanes and cargo flights from the various observatories to supercomputing centers in the United States and Germany was the only mathematically viable way to transfer the petabytes of information. When the supercomputers finally stitched the radio waves together, correcting for the atmospheric noise and the rotation of the Earth, The resulting image confirmed the most extreme predictions of general relativity. The image revealed a bright, asymmetrical ring of fire surrounding a perfectly dark central region, the shadow of the black hole. But it was the asymmetry of that ring of fire that revealed the terrifying dynamics of the accretion storm. The ring was noticeably brighter on the lower side. This was not because the plasma itself was hotter in that region, but due to a relativistic optical illusion known as Doppler beaming. The plasma in the accretion disk is swirling around the black hole at velocities approaching the speed of light. As the superheated gas races on the side of the disk, moving toward our telescopes, the laws of special relativity compress the light waves, intensely amplifying their brightness. As the plasma completes its orbit and races away from us on the far side of the black hole, the light is stretched and dimmed. We are looking at a hurricane of fire so fast that it physically warps the trajectory of its own photons. However, the accretion disk is merely the horizontal component of this cosmic weather system. The true devastation occurs along the vertical axis. The superheated plasma of the disk is entirely composed of charged particles, electrons and protons violently ripped apart by the heat. As these particles orbit the black hole at relativistic speeds, they generate an immense, twisting magnetic field. Because the inner layers of the disk orbit faster than the outer layers, these magnetic field lines do not remain orderly. They are dragged, stretched, and tightly braided into a dense vertical funnel, rising directly above the north and south poles of the black hole. This magnetic funnel acts as the most powerful particle accelerator in the universe. Not all the matter in the accretion disk is swallowed by the event horizon. A significant fraction of the infalling material is violently redirected by the magnetic turbulence. It is caught in the rotating magnetic lines and accelerated outward, funneled into two narrow beams of pure plasma shooting out from the poles. These are relativistic jets. The physical mechanics of these jets defy human comprehension. The magnetic fields collimate the plasma, keeping the beam incredibly tight and focused even as it punches through the interstellar medium of its host galaxy. The particles within these jets are traveling at 99.9% of the speed of light. Because they are moving so fast, the particles themselves experience extreme time dilation. The physics of relativity dictate that the faster an object moves through space, the slower it moves through time. From the perspective of an electron riding the crest of this jet, a journey that takes thousands of years across the galaxy happens in an instant. When one of these relativistic jets happens to be pointed perfectly along our line of sight, aiming its cosmic artillery directly at Earth, we call the object a blazar. Looking at a blazar is like staring down the barrel of a blindingly bright searchlight piercing through the fog. The radiation we receive from a blazar fluctuates wildly, surging in brightness over the course of hours or days. This violent flickering is the direct signature of the chaotic, storm-like turbulence feeding the black hole millions of light years away. We are witnessing the uneven digestion of whole stars and planetary systems, translated into erratic bursts of gamma rays and X-rays washing over our planet's atmosphere. You might assume that such apocalyptic weather is a distant phenomenon, confined to the ancient active galaxies at the edge of the observable universe. But the machinery of the cosmos operates on cycles of dormancy and extreme violence. Our own Milky Way galaxy harbors a supermassive black hole known as Sagittarius A star, resting quietly 4 million times more massive than the Sun. Currently, it is starving. It feeds on a meager diet of thin interstellar gas, producing an accretion disk that is remarkably dim. But this localized piece is a temporary illusion. In the year 2010, astronomers analyzing the data from the Fermi Gamma Ray Space Telescope discovered something massive and utterly inexplicable looming over our galaxy. Stretching 25,000 light-years above and below the galactic center are two colossal, faintly glowing structures known as the Fermi bubbles. They are invisible to the naked eye, emitting radiation primarily in the high-energy gamma ray and X-ray spectrums. These gargantuan lobes of hot gas and cosmic rays are the lingering ghosts of a cataclysmic storm. The physical dimensions and energy signatures of the Fermi bubbles suggest that just a few million years ago, an instant in the geological timescale of our planet, right around the time the first early hominids were walking the African savannas, Sagittarius A star woke up. A massive cloud of gas, or perhaps a cluster of stars, wandered too close to the galactic center and was shredded by the gravitational tides. The sudden influx of matter ignited a furious accretion disk, and the dormant giant unleashed a blistering relativistic jet that bored through the poles of the Milky Way, blowing a massive cavity into the halo of the galaxy. The shockwave from that ancient eruption is still expanding outward today. We are living in the quiet aftermath of a galactic hurricane, existing in a temporary window of calm. But the celestial mechanics are entirely unsentimental, and the equations demand a return to chaos. In roughly 4 billion years, the Andromeda Galaxy, currently racing toward us at 250,000 miles per hour, will collide with the Milky Way. This is not a theory. It is a mathematical certainty written in the Doppler shift of Andromeda's light. When the two galaxies merge, the delicate gravitational architecture holding our quiet neighborhood together will be entirely rewritten. The vast clouds of interstellar gas from both galaxies will violently collide, compressing and igniting widespread star formation. But more terrifyingly, the supermassive black holes at the centers of both galaxies will be drawn together in a decaying, spiraling orbit. As they close in on each other, they will forcefully drag the surrounding galactic gas with them, providing an ocean of fuel for a new era of violent accretion. The skies of whatever remains of our solar system will be illuminated by the blinding, radiation-soaked glare of twin quasars igniting in the dark. Yet as we calculate the raw power of these phenomena, tracing the path of the plasma and measuring the extreme velocities of the jets, we encounter a boundary where observation ceases. As the matter spirals closer and closer to the crushing singularity, spinning faster and burning brighter, it crosses a mathematically defined line in the sand. At this threshold, the behavior of the storm stops obeying the rational laws of thermodynamics and fluid dynamics that we have spent centuries verifying. The mathematics begin to produce infinities. The very fabric of reality, the grid upon which the storm is raging, begins to crack. We call this mathematically defined line in the sand the event horizon. It is not a physical surface. There is no solid crust to crash into, no dense atmosphere to penetrate, no tangible wall separating the storm outside from the void within. It is purely a geometric boundary drawn by the relentless equations of gravity. To understand the event horizon, imagine a vast, deep river flowing relentlessly toward a massive waterfall. Far upstream, the water moves slowly. A fish swimming in this current can easily maneuver, fighting the flow and moving in any direction it chooses. But as the river nears the drop, the riverbed narrows and the water accelerates. There is a specific invisible line in the rushing water where the speed of the current exactly matches the maximum speed the fish can swim. Once the fish crosses that microscopic threshold, its fate is absolutely sealed. It cannot swim fast enough to turn back. It does not feel a wall. The water around it feels exactly the same as it did a moment before. But the geometry of its reality has been fundamentally altered. All possible futures now lead inevitably over the edge. The event horizon is the point where the current of space itself is falling inward faster than the speed of light. Because nothing in the physical universe can exceed this cosmic speed limit, nothing that crosses this threshold can ever return. The blindingly bright, violently rotating plasma of the accretion disk is constantly feeding material across this boundary. But no signal, no photon, no echo of that matter will ever escape back into the galaxy. The storm simply vanishes into the dark. But this is where our human intuition and our current understanding of physics begins to critically fail. We are forced to confront a brutal paradox dictated by Albert Einstein's theory of general relativity. The math tells us that gravity is not merely a force pulling objects together. It is the physical warping of space and time. The stronger the gravitational pull, the slower time moves relative to an outside observer. As an object is dragged from the accretion disk closer and closer to the event horizon, the extreme gravity subjects it to catastrophic time dilation. Think of the latency on a heavily overloaded global computer network. When a server is pushed beyond its capacity, a process that should take milliseconds stretches into agonizing, seemingly infinite delays. The data is still moving, but the perception of its movement grinds to a halt. The event horizon is the ultimate server crash of reality. If you were watching a star plunge toward the black hole from a safe distance, you would never actually see it cross the threshold. As the star approached the edge, its light would become severely stretched and dimmed, shifting deep into the infrared and radio frequencies. The star's movement would appear to slow down, becoming increasingly sluggish until it seemed to freeze entirely, suspended in absolute stillness right on the precipice of the abyss. From your perspective, that star would hang there for the rest of eternity, a ghostly red silhouette slowly fading into nothingness. Yet for the matter inside the star itself, there is no slowing down. For the collapsing star, time proceeds perfectly normally. In its own frame of reference, it crosses the horizon in a fraction of a second, plunging into the darkness at relativistic speeds. This creates a deeply unsettling duality in our universe. Two opposing realities exist simultaneously, depending entirely on where you are standing. In one reality, the star is frozen forever on the outside. In the other, it has already been violently consumed. And the terrifying truth is that the mathematics of relativity declare both perspectives to be absolutely, perfectly correct. This duality is merely the first crack in the foundation. As we attempt to trace the path of the consumed star deeper into the darkness, moving past the event horizon and toward the absolute center of the black hole, we encounter an impenetrable barrier. It is not a physical wall, but a theoretical dead end where the entire architecture of modern science collapses in on itself. For the past century, our understanding of the universe has been supported by two magnificent, fiercely tested pillars of physics. The first is general relativity, the language of the macrocosmos. It describes a universe that is perfectly smooth, a continuous, seamless fabric of space and time shaped by the heavy celestial bodies that rest upon it. It operates with absolute deterministic precision. You calculate the mass, you calculate the trajectory, and you can predict the movement of a galaxy millions of years into the future. The second pillar is quantum mechanics, the language of the microscopic realm. It describes the chaotic nervous energy of atoms, electrons, and photons. Unlike the smooth fabric of relativity, the quantum world is fundamentally pixelated. If you zoom in close enough on the fabric of reality, it stops being smooth and breaks down into tiny, indivisible packets of energy. It is a world that abandons deterministic certainty in favor of probability and intrinsic randomness. It operates more like the erratic static of a disconnected radio than the predictable gears of a mechanical clock. For decades, these two theories have existed in a state of hostile segregation. We use relativity to calculate the orbits of planets, and we use quantum mechanics to engineer the microchips inside our computers. As long as we keep the massive objects far away from the microscopic objects, both theories work flawlessly. But a black hole brutally forces these two incompatible realms to collide. The immense mass of a dead star, governed by relativity, is crushed down by its own gravity into an infinitely small point, a microscopic arena governed strictly by quantum mechanics. When theoretical physicists attempt to combine the equations of Einstein with the mathematics of the quantum world to describe the center of a black hole, the singularity, the resulting calculations are a catastrophic failure. The equations violently break apart, spitting out infinities. They calculate infinite density occupying zero volume, generating infinite gravitational curvature. In the cold, precise realm of mathematics, an infinity is not a profound philosophical truth. It is a giant, screaming warning sign. It means the equation is fundamentally broken. It means the theory has lost its grip on reality. We have reached the absolute limit of human knowledge, staring blindly into a region of space where the laws of physics simply cease to exist. The frustration of this barrier drove physicists to look closer at the absolute edge, returning their focus to the event horizon itself. If we cannot understand the center, perhaps we can decipher the boundary. In the 1970s, a brilliant and esoteric theoretical breakthrough completely shattered our understanding of the cosmic storm. The realization came from acknowledging that the vacuum of space is not a true, empty void. In the framework of quantum mechanics, A perfect vacuum is impossible. Space is not an empty stage. It is a boiling, chaotic soup of temporary energy. Due to the inherent uncertainty of the quantum realm, pairs of particles, one composed of matter and the other of antimatter, are constantly popping into existence out of nothingness. They borrow an infinitesimal amount of energy from the vacuum, exist for a fraction of a nanosecond, and then violently collide, annihilating each other and returning the borrowed energy back to the void. This microscopic storm of virtual particles is happening everywhere, constantly, all around us. It is the inescapable background noise of reality. Under normal circumstances, this constant creation and destruction goes entirely unnoticed. But the mathematics demanded we ask what happens when this quantum boiling occurs exactly on the razor-thin edge of an event horizon. Imagine a pair of these virtual particles popping into existence right on the boundary line. In that impossibly brief moment, before they can annihilate each other, the extreme gravitational tidal forces rip them apart. One particle happens to form just inside the event horizon. The relentless current of space drags it instantly down into the singularity. The other particle, forming just a millimeter outside the boundary, is violently accelerated outward, escaping into the cold expanse of the galaxy. Because the particles did not annihilate, the energy they borrowed from the vacuum was never repaid. The laws of thermodynamics are absolute. Energy cannot be created from nothing. The universe balances its ledger by forcing the black hole itself to pay the debt. The black hole must give up a microscopic fraction of its own mass to compensate for the escaping particle. This means that the black hole is not entirely black. It is glowing incredibly faintly, with a steady stream of escaping quantum radiation. And because it is constantly losing mass to fuel this radiation, the black hole is slowly shrinking. It is evaporating. The mathematics describing this evaporation process reveal a merciless truth. The temperature of a black hole and the rate at which it bleeds radiation into space is strictly and perfectly inversely proportional to its mass. The massive, terrifying monsters at the centers of galaxies are incredibly cold, leaking energy so slowly that their evaporation timescale stretches into numbers of years that require pages of zeros to write down. But as the black hole shrinks, its temperature begins to rise. A black hole the mass of a large mountain would glow fiercely with the heat of a star. A black hole the size of an atom would burn with unfathomable, apocalyptic heat, accelerating its own evaporation in a runaway feedback loop until it detonates in a blinding flash of hard gamma radiation. The realization that black holes evaporate should have been a triumph, a beautiful bridge connecting the gravity of the cosmos with the quantum mechanics of the microscopic. Instead, it triggered the deepest and most profound crisis in the history of theoretical physics. It birthed a nightmare known as the information paradox. To understand why this paradox threatens to destroy physics, we must understand how science defines information. We do not mean information in the sense of data on a hard drive or words in a book. We mean the fundamental quantum state of every particle in the universe, the precise arrangement of atoms, the specific spin of every electron, the exact velocity of every proton. In the macro world, things seem to be easily destroyed. Imagine throwing a heavy, leather-bound book into a roaring fireplace. The paper blackens, curls, and bursts into flame. The binding melts. Within an hour, all that remains is a pile of grey ash, escaping heat and smoke rising up the chimney. To human eyes, the book is gone. The story written on its pages is permanently erased. But to the strict, uncompromising laws of quantum mechanics, the book has not been destroyed at all. It has only been scrambled. The fundamental law of quantum physics dictates that quantum information is absolutely conserved. It can never be created, and it can never, under any circumstances, be completely erased. If you possessed a theoretical supercomputer of infinite power, and you could perfectly track the trajectory of every single molecule of smoke, measure the exact temperature of every photon of heat, and analyze the chemical structure of every flake of ash, you could mathematically run the physics in reverse. You could trace the microscopic chaos backward, reassembling the smoke, the heat, and the ash to reconstruct the exact text printed on those pages. The information survives the fire. Now, Replace the fireplace with a supermassive black hole, and replace the book with an entire solar system, planets, moons, atmospheres, and everything on them. The black hole swallows the solar system. For billions of years, that matter is locked inside the singularity. Then slowly, the black hole begins to evaporate through quantum radiation. The energy leaks back out into the universe. Eventually, the black hole shrinks to nothing and vanishes entirely. Here is the fatal problem. The mathematics strictly dictate that the escaping radiation is entirely random. It is completely featureless thermal noise. It carries absolutely no imprint, no memory, and no quantum data about the material that originally fell into the abyss. The radiation produced by a black hole that swallowed 1 billion tons of pure lead is mathematically indistinguishable from the radiation of a black hole that swallowed 1 billion tons of water. When the black hole finally finishes evaporating, the original quantum information of the solar system is not just scrambled like the ashes of the book. It is completely gone. It has been permanently deleted from the hard drive of reality. This is the information paradox. If the information is truly lost, then quantum mechanics, the theory upon which all modern chemistry, biology, and technology is built, is fundamentally incorrect. The rules we use to understand the fabric of our existence are broken, but if the information is somehow preserved and escapes with the radiation, then general relativity, the theory we use to understand gravity, the stars, and the expansion of the universe itself, must be fatally flawed. Our two most successful frameworks for understanding reality are locked in a zero-sum deathmatch, and one of them must be completely wrong. Desperate to save the foundation of science, theoretical physicists proposed an incredibly controversial and terrifying solution. They reasoned that if the information must escape, it must be encoded in the outgoing radiation. But for this to happen, the fundamental rules of quantum entanglement must be severely stressed. The particles escaping the event horizon must remain deeply entangled with the particles falling inward. The mathematics of entanglement are rigid. A particle cannot be fully entangled with multiple independent systems at the same time. To preserve the information on the outside, the microscopic connections between the matter falling into the black hole and the matter already inside must be violently severed exactly at the boundary. Breaking millions of quantum bonds simultaneously requires an unfathomable release of energy. This theory suggests that the event horizon is not an invisible, unnoticeable line in the dark. The mathematical consequence of breaking these bonds creates a literal wall of searing high-energy plasma sitting perfectly on the boundary. They call it the firewall paradox. If this theory is true, everything we thought we knew about crossing into a black hole is a lie. You would not experience the slow, strange time dilation of a smooth passage. The current of space would not simply carry you quietly over the edge. Instead, the moment an object touched the mathematical boundary of the event horizon, it would instantly crash into a microscopic storm of pure incinerating quantum fire. It would be vaporized into fundamental particles before it ever had a chance to fall into the dark. The firewall represents the ultimate physical barrier, a theoretical shield of devastation that actively prevents us from ever looking inside. We are left standing in the dark, watching the most violent storms in the universe raging across the void, fundamentally unable to understand how they end. The equations have turned against us, leaving us trapped in a universe that is either destroying its own history or burning anyone who tries to look too closely at the truth. The crisis of the firewall and the deletion of information is not merely an abstract mathematical puzzle confined to the edge of a collapsed star. It is a fundamental crack in the architecture of reality that bleeds out into our understanding of everything. If the extreme gravitational storms of a black hole can literally burn away the history of the matter they consume, then the universe is not the perfect, infallible ledger of cause and effect we believed it to be. It implies that the cosmos has a built-in mechanism for permanent amnesia, and the consequences of this realization force us to completely dismantle our perception of our place in the universe, starting with the deeply flawed human illusion of time. On Earth, we experience time as a steady, universal metronome. A second passes for you, and a second passes for the rest of the planet. We assume this synchronization extends upward into the stars, that the universe shares a single ticking clock, but general relativity has already proven this to be a biological hallucination. Time is not a rigid grid. It is a highly malleable fluid, deeply sensitive to the presence of mass and the speed of motion. The immense gravitational engines we have discussed do not just warp the physical space around them. They warp the very flow of the future and the past. If you could somehow construct a heavily shielded observation station in a tight orbit just outside the event horizon of a supermassive black hole, you would not just be watching a violent storm of plasma, you would be standing entirely outside the chronological progression of the galaxy. Because the gravity is so immense, the time dilation is absolute. For every minute you spend watching the swirling accretion disk from your window, entire millennia would pass in the wider universe. You would watch the surrounding stars age, exhaust their nuclear fuel, and die out in what appears to you as rapid-fire time-lapse photography. The future of the cosmos would play out before your eyes in a matter of days. You would become a spectator to deep time, entirely disconnected from the reality of the human race, which would have risen, built its empires, and turned to dust in the space of a single breath you took. This breaks the concept of now. There is no universal present. The terrifying atmospheric phenomena we observe in deep space are not happening right now in any meaningful sense. We are receiving the light from quasars that died billions of years ago. The universe is a fragmented tapestry of delayed signals and isolated timelines held together by the absolute speed limit of light. We are entirely cut off from the true current state of the cosmos, forever trapped in a localized bubble of the past, trying to make sense of a reality that has already moved on. But the distortion of time is only the beginning of the existential unraveling. The attempt to solve the information paradox birthed a mathematical framework so fundamentally unsettling that it challenges the very definition of a physical universe. When physicists scrutinized the thermodynamic properties of black holes, they discovered a relationship that made absolutely no logical sense in a three-dimensional world. The mathematics dictate that the entropy of a black hole, the exact measure of its hidden quantum information, the chaotic data of every swallowed star and planet, does not depend on the three-dimensional volume inside the event horizon. It depends strictly on the two-dimensional surface area of the horizon itself. To understand how profoundly wrong this feels, imagine a colossal subterranean library holding the sum of all human knowledge. Common sense and standard earthly physics dictates that the amount of information the library can hold is determined by its volume. If you want to store more books, you must dig deeper and build a larger room. But the mathematics of a black hole state the exact opposite. They reveal a reality where the volume of the room is completely irrelevant. The absolute limit of information that can be stored is determined solely by the square footage of the walls enclosing the room. It is as if the books themselves do not actually exist in the empty space of the room, but are somehow perfectly encoded as two-dimensional data painted on the microscopic surface of the walls. This mathematical compromise birthed what theoretical physicists call the holographic principle. If the ultimate gravitational engines in the universe encode their swallowed three-dimensional reality perfectly onto a two-dimensional boundary, and if black holes are a natural, inevitable consequence of the geometry of space-time, then the rule must apply everywhere. The mathematics suggest that our entire three-dimensional universe, with its depth, its passing time, its violent storms, and its solid matter, might simply be a holographic projection. We perceive depth and volume because our brains evolved to survive in a low-resolution rendering of a much deeper, entirely inaccessible reality. The true physics of the universe might be playing out on a flat, unimaginable boundary billions of light-years away, and everything we feel, touch, and study is just the translated interference pattern of that distant data. The physical universe is not the hardware, it is merely the software. We are living inside the rendering engine of an indifferent mathematical truth. When we internalize this, the true scale of the cosmic weather systems begins to feel less like meteorological events and more like fundamental reboots of the system. And just as our understanding of the universe's architecture is terminal, so too is its long-term forecast. We currently live in what astrophysicists call the stelliferous era, It is a brief, beautiful, and highly active window of cosmic time where the conditions are just right for vast clouds of hydrogen to collapse, ignite, and form stars. We look up and see a sky burning with nuclear fire. But the laws of thermodynamics demand an end to this activity. The universe is a machine with a finite amount of fuel, and it is slowly, irreversibly winding down. Fast forward 100 trillion years. The last of the red dwarf stars, the slow-burning embers of the cosmos, will finally exhaust their hydrogen. They will quietly fade into cold, dead husks. The violent, beautiful supernovas that seeded the galaxy with heavy elements will cease. The sky will go entirely dark. The universe will enter the degenerate era. In this pitch-black, freezing void, the expansion of the universe, driven by the relentless and unexplained force of dark energy, will have pushed the dead galaxies so far apart that the light from one could never mathematically reach another. Every remaining structure will be entirely isolated, floating alone in an ocean of nothingness. The only active weather systems left in reality will be the silent, invisible mechanics of gravity operating on dead matter. The universe will be populated exclusively by frozen planetary cores, wandering neutron stars, and the reigning monarchs of the dark, the supermassive black holes. With no gas left to feed their accretion disks, the spectacular plasma storms and relativistic jets will be a distant memory. The black holes will roam the dark, pulling in the occasional dead star, emitting no light, leaving no visible trace. But occasionally, over timescales that defy human comprehension, two supermassive black holes will find each other in the dark. Their merger will not produce a spark of light, but it will unleash the most violent mechanical storm possible in the fabric of space. As the two singularities spiral inward and collide, they will convert a massive percentage of their combined mass directly into pure gravitational energy. This energy radiates outward as gravitational waves, literal physical ripples in the fabric of space and time. A passing gravitational wave from such a merger does not blow wind or emit heat. It physically stretches and compresses the distance between atoms. If you were floating near this merger, you would be stretched and crushed repeatedly as the very grid of your reality vibrated violently. These silent, invisible tsunamis of warping space will be the only storms raging in the long, dark twilight of the universe. But even the black holes, the ultimate engines of destruction, are not immortal. We must look further ahead, past the degenerate era, deep into the black hole era. A period of time so distant that expressing it requires a 1 followed by 100 zeros. It is a timescale where the word trillions loses all meaning entirely. In this era, the only thermodynamic process left operating in the entire cosmos is Hawking radiation, the microscopic quantum boiling at the edge of the event horizons. Slowly, agonizingly, particle by particle, the supermassive black holes will begin to evaporate. They will bleed their immense mass back into the freezing void as a faint, imperceptible mist of thermal radiation. For eons, this process is agonizingly slow. The universe is a silent, decaying graveyard. But as the black holes lose mass, the mathematics dictate that their temperature must inevitably rise. As they shrink to the mass of mountains, they will begin to glow. As they shrink to the size of boulders, they will burn with a brilliant, blinding white heat, entirely alone in the darkness. The evaporation process accelerates into a runaway, unstoppable thermal cascade. In its final microscopic fraction of a second, the black hole will reach absolute critical mass. It will violently detonate, releasing the energy of 1 billion nuclear arsenals in a single perfectly spherical flash of hard gamma radiation. This solitary, blinding explosion in the absolute dark will be the final weather event in the history of reality. One by one, over unfathomable spans of time, the last remaining black holes will detonate and fade. When the final singularity evaporates, it will leave behind a universe composed of nothing but a thin, perfectly even mist of photons and fundamental particles, stretched infinitely thin across a void that continues to expand forever. There will be no gravity left to pull matter together. There will be no thermal gradients left to drive a wind. There will be no energy left to encode a single thought. The universe will finally achieve maximum entropy. It will reach the absolute permanent thermodynamic equilibrium known as the heat death. The mechanics of the cosmos do not care about the civilizations that once looked up at the stars. They do not care about the empires that fell, the equations that were written, or the information that was lost. The storms we observe today, the shredding of stars, the relativistic jets, the magnetic hurricanes, are not tragedies. They are merely the necessary mechanical steps in a relentless process that demands absolute silence. We are forced to sit with the math, staring at the timeline of our own cosmic erasure, left to reconcile the fact that every storm, every star, and every breath we take is just a fleeting, highly localized anomaly in a machine that is slowly tearing itself apart. We return to the surface of our pale blue dot. We step outside, look up at the night sky, and because our biological clocks tick in microscopic fractions of a century, we perceive a serene and unchanging canopy of stars. We feel secure in our isolation. We watch our localized atmospheric pressure drop. We board up our windows against the wind, and we call it a catastrophic storm. We survive it. We rebuild our concrete structures, and we feel deeply resilient. But true perspective is a terrifying thing to acquire. To truly understand the mechanics of cosmic weather is to realize that our planetary safety is entirely illusory. We are living inside a temporary sanctuary, shielded from the true violence of reality by nothing more than a fragile, temporary layer of nitrogen and oxygen. We are forced to confront the fact that we are not the protagonists of this reality. We are a fleeting biological byproduct of a highly localized thermodynamic imbalance, clinging desperately to a cooling rock that orbits a remarkably average star. The sheer, overwhelming hostility of the broader universe is not directed at humanity with malice. It is simply and completely oblivious to the fact that we are here. The relativistic jets boring through galaxies, the supersonic winds of jagged glass, the violent magnetic shearing of plasma oceans, and the slow, inevitable evaporation of singularities. These are the actual normal conditions of the void. They are the standard operating procedures of a cosmos that operates with a cold mathematical brutality, making absolutely no exceptions for the delicate architecture of carbon-based life. For millennia, humanity has built towering monuments, authored intricate philosophies, and successfully mapped the fundamental physical forces of nature in a desperate, collective attempt to assert our meaning against the dark. We convince ourselves that our expanding scientific knowledge grants us a degree of permanence, that by understanding the storm, we somehow conquer it. But the very equations we have so proudly discovered offer absolutely no salvation. They are simply the unyielding blueprints of our own eventual permanent erasure. The cosmic storms will relentlessly continue to churn in the deep dark, stripping ancient galaxies of their life-giving gas, crushing physical matter down into infinite density, and slowly radiating the history of everything into a featureless, freezing, scattered mist. The universe is not a nursery. It is a perfect, inescapable machine designed to ultimately exhaust itself. When the final black hole finally detonates in the deep future, and the long dark era of absolute inescapable entropy settles in, there will be no surviving record of the Earth. There will be no memory of our deep oceans, our towering cities, or the localized, gentle weather systems we once feared. The terrifying information paradox will quietly resolve itself in the absolute, dead silence of the void. Our entire human history, from the first spark of discovered fire to the final, desperate observation of a fading quasar, will be mathematically reduced to absolute zero. We are nothing more than a temporary spark caught inside a hurricane of unimaginable gravitational violence. We are quietly witnessing the slow, majestic, and completely unavoidable death of a reality that never asked for our presence. The night sky is not a comforting roof over our heads. It is an open window into the crushing depths of the abyss, and the abyss is completely indifferent to the fact that we are watching.